We can start, sir. We can start the session.
They will ask questions also.
We can start, sir. Then after that, they will ask questions.
Okay, where those questions will be visible?
One second, sir.
Shall we begin, madam?
Hello, sir.
Yeah, hello.
We can start.
Welcome to the RRR YouTube series from
Recording in progress.
StudyMEDIC. Myself, Dr. Avinash, and I will be guiding you through the concepts in biostatistics. These are the concepts which we'll be discussing today, and they are measures of central tendency, dispersion, and diagnostic accuracy tests. So these are the concepts we'll be discussing. This will basically help us understand these concepts and also be able to analyze the problems based on these topics and solve these questions in our exams. So what are these measures of central tendency? Means those measures that show us the central most value. They are mean, median, and mode. So we all know the measures of central tendency are mean, median, and mode. Whereas the measures of dispersion are standard deviation, interquartile range, and coefficient of variation. Now we will see what is mean. So mean is nothing but sum average. That is, we add all the data and divide it by total number of the data. So the mean can be for the sample. That is called as the sample mean. Whereas the mean can be from the population from which the sample is drawn. Suppose this is the population from which the sample is drawn. The population mean means the mean of the data of the population, whereas the sample mean means mean of the data of the sample. So it is represented sample mean as X bar. So you can see sigma of all the values, that is total of all the values divided by the total number of sample. Whereas mu is population mean, it is again sum of all the values divided by the sample size n, that is a population size. So that is the mean. Now we will see how do we calculate this mean, because most of the times some questions may be asked, and we will also understand the concept of the mean by solving this. Now following are the neonatal birth weights, right? Following are the neonatal birth weight in 10 women with anemia. So these are the birth weight 1.2, 1.31, etc., etc. What is the mean birth weight? Now how do we calculate this? So we need to add all this, right? 1.2 plus 1.3 plus 1 plus 0.9 plus 0.8 plus all. So we add and divide it by, see how many women are there? 10. So we are divided by 10. So it will be equal to 13.6 divided by 10, that is 1.6 and 36 and approximately 1.4 kg is the answer. So 1.4 kg is the mean neonatal birth weight in this sample, okay, drawn from the population. So this is the mean. How do we calculate? Now, suppose another sample is drawn from the same population, and this time instead of 2 kg, a woman means 2 kg, neonatal birth weight of 0.5 kg was recruited in the sample. We are drawing the sample from the same population, but a different sample this time, right? So what will happen to the mean in this case? So when we see that, when we add and divide it by the total number, sum of all values by total number of values, what will happen? Here you can see when we add, the total number will be 12.1 divided by 10, and the mean is now 1.2. Earlier the mean was 1.4 kg. Now the mean is 1.2 kg. Why? It is because a sample of 0.5 kg neonatal birth weight has been recruited in this. However, it is drawn from the same population. Now, what is our observation here? The mean gets affected by these extreme values, either on the lower side or on the higher side. It is drawn towards it. Now you can see it is drawn towards the lower side. So it has reduced. So mean gets affected. Now, why and what is the implication of this? What is the implication of this? We will see when we compare mean with median. So what is the median? Median is the centralmost value in the sorted data set. Means when we arrange all data either in increasing or decreasing order, it is called as a sorted data set. Now, next we find the centralmost value that has equal number of data on either side of it. Then it is called as the median. So that value which has the centralmost and on either side it has equal number of data. That is called as the median. So how do we find out median? Visually also you can sort and then find out. However, there are formulas to find out the median. When total number is odd, that is odd number, total number is an odd number, then median is the n plus 1 by 2, that value, n plus 1 by 2th value. And when n is even numbered value, that is the sample size is even numbered, then median will always be average of the n by 2th value and the next value. Average of the n by 2th value and the next value, right? So now we know what is median. Let us see whether we can solve some of the problems associated with it. Now we have selected the same sample, right? But in this case, the sample size is 11 and these are the neonatal birth weights, right? Now what we need to do to find the median, we need to arrange them in the order. So we have arranged them. So this is the order and you can see 1.2 is the median here. How we found out visually is on either side of 1.2 there are 1, 2, 3, 4, 5 on the right side and the 5 values are on the left side of the median. So equal number of value lies on either side of the median. So that is the data. That is the median is 1.2. Here the number of sample is odd, that is n is equal to 11. So it is easier to find. Now, if we use the formula of n plus 1 by 2th value, how we are going to calculate the median? Then if n is equal to 11, then n plus 1 by 2th value is the 6th value. So first, second, third, fourth, fifth and the 6th value is equal to 1.2 and that is the median, right? Now we can see what was the mean here. It was 1.4. The median is 1.2. Let us see what will happen when we draw a sample which is replaced. Okay. Now which is replaced by even number. Sorry, this is not 11. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So now we have a sample of 10 here. Okay. So we can see that if the even number data is presented, how do we calculate the median? So the median is calculated as as we discussed, the average of the middlemost values. So arranged in ascending or descending order, then take the average of the middlemost values. So you can see the middlemost values are 2, 1.2 and 1.3. Take the average of this. So add this and divide by 2, that will get the average. Okay. Or you can use the formula. So what is the median when n is even? It is the average of n by 2th value and the next value. What is n by 2th value? 10 by 2 is the 5th value. 1, 2, 3, 4. 5th value is 1.2 and the next value is the 6th value. It is 1.3. So we take the average and we get it as average is 1.2 and 1.3 average is 1.25. So this is how we calculate the median when n is even numbered. Right. Now, if we take the same sample, but this time, as we can see, a low birth weight of 0.5 is recruited in the sample from the same population, then we shall see what will happen to the median. Is it affected? See, we arranged that in the ascending order, right? So a low birth weight instead of 0.8 kg, which was the low birth weight in the previous example. So 0.8 kg is the low birth weight in the previous example. Now in the next example, instead of 0.8, a 0.5 kg birth weight is recruited in the sample. So what will happen? So we can see the median still is the average of 1.2 and 1.3, which is equal to 1.25. So median is not affected by the extreme outlier here. Whereas mean gets affected by the extreme outlier. The median still remains the same. Okay. So this problem illustrates that mean is affected by the extreme outliers and median is unaffected by the extreme outliers. Now we will see which of the following statement is true about mean. So mean considers all values to calculate central tendency. Is it true? Yes, it considers. It is the sum average. Mean is a better measure of central tendency when population is normally distributed. So it is also yes. Okay. So mean is always a better measure of central tendency when population is normally distributed, because normally distributed population will not have the extreme outliers. Mean is affected by extreme outliers. This is also true. Mean is not a better measure of central tendency when population is not normally distributed. Yes. Mean is only a better measure of central tendency when it is normally distributed, whereas it is not a better measure of central tendency when population is not normally distributed. Then what is correct? All of the above are true. These are the true statements about mean. Now we will see which of the following statement is false about mean or median. Which of the following statement is false about the median? Okay. So which of the following statement is false about the median? Median considers all values to calculate central tendency. No, median will not consider all values to calculate central tendency. It is wrong. Median is a better measure of central tendency when population is normally distributed. This is also wrong. Actually, median is a better measure of central tendency when the population is not normally distributed, because it is not affected by the extreme outlier. Median is affected by extreme outliers. No, this is also wrong. Median is unaffected by the extreme outliers. Median is not a better measure of central tendency when population is not normally distributed. This is also wrong. Median is a better measure of central tendency when population is normally distributed. So all the above statements are wrong about this. Now we will see whether we can identify the type of the graphs and see the effect of the distribution of the data on the central tendency. Okay, so we will see that. Now, what is this graph A? What is this graph B? And what is this graph C? Identify the type of the distribution. As we can see, graph A, it is bell-shaped curve and it is very symmetric. So this distribution is bell-shaped Gaussian normal distribution. That is a symmetric normal distribution. Whereas the graph B, you can see that the values are deviating, means there are high values on the right side. Okay, so you can see extreme values are on the right side. So graph is skewed towards the right, right? Then it is called as a positively skewed graph. Whereas in graph C, there are extreme outliers on the left side, that is on the lower side. So the distribution is skewed towards the left and it is called as the negative skewed graph or the distribution. Okay, so this is a symmetric distribution A, B is the positive skewed distribution and C is the negatively skewed distribution. So this is how we identify the type of the distribution. Now the next question is, in which type of the distribution mean, median and mode are equal? It is in the symmetric distribution. Mean, median and mode are usually equal or the same in the symmetric distribution. Now, in which type of the distribution mean is actually more than median? Because we now see that mean is affected by the extreme outliers and it is drawn towards the higher or lower values, right? So in which type, whereas median is unaffected. In which type of distribution then mean is more than median? It is in the positively skewed distribution. As you can see, mean here is more than the median, right? Mean is here more than the median. Median still remains the same. Now, in which type of the distribution mean is less than the median? Yes. Now we can guess that it is in negatively skewed distribution. Mean is less than the median, as mean is drawn towards the lowermost extreme or lower values. So this are some of the graphs, and this is how we identify the distribution and we understand the characteristics of this distribution. Now, coming to the measures of dispersion. One of the important measure of dispersion is the standard deviation. Now let us see and understand what is the standard deviation. Now if the mean value, let me draw and show you. When the mean value, okay, when the mean value is 2.83 mean value, okay. So suppose these are the values of the uric acid levels in hyperuricemic women. Okay, so what is the mean value? There are 5 women and the mean uric acid level is 2.83. So this is the mean uric acid level, 2.83. What is the value of the first woman? That is 1. So this is this much far from the mean. What is the second sample? It is 2. This is this much far. And third sample is also 2. Fourth sample is 3. It is positively more. This much more. Fifth sample is value is 4. And the sixth sample value is 5. So these are this much far. Now when we add all this variation of each value from the mean, okay, this is the variation of each value from the mean. When we add all this, when it is normally distributed, it will be equal to 0. So that's why we cannot use the distribution how much the each value, sum of all the, how much each value is away from the mean. We cannot use the sum because it will be 0. Instead, we square that. So we square the differences between each value and the mean, and then we add all those square differences and divide it by the n-1 with a degree of freedom of 1. Okay, so that is called as variance. But what it is a squared value. So it is not, we don't want the squared variation. So what we do is we take the square root of the variance, and then it is called as the standard deviation. So standard deviation is the square root of the sum of the squared mean differences. Square root of the sum of the squared mean differences. That is called as the standard deviation. Okay, right. So only appropriate when the continuous data is not significantly skewed. That means we can use standard deviation along with mean to represent the variation in the continuous data if it is not significantly skewed or has no outliers, because similar to mean, the standard deviation also gets affected by the outliers. And this standard deviation is always used in conjunction with the mean to summarize the continuous data, and it cannot be used to summarize the categorical data. So this we have to remember. Now we will see what is the characteristics of this standard deviation. Which of the following statement is true about standard deviation? Standard deviation considers all values to calculate central tendency. Is it true? No. It is the standard deviation actually considers all values to calculate the dispersion. Okay, standard deviation calculates the dispersion. Okay, all values. It considers all values because the difference between each value from the central value is considered, but it calculates dispersion. Okay. Standard deviation is a better measure of dispersion when population is normally distributed. Yes, it is true, because when it is not normally distributed, there will be outliers, high or low values, very high or very low values, and they affect the SD, like mean. SD is affected by extreme outliers. Yes, this is also true. X3 is affected by extreme outliers. Okay. SD is not a better measure of dispersion when population is not normally distributed. This is also true. SD is a better measure of dispersion only when the population is normally distributed. Okay, so these are the statements that are either true or false about the SD. So more is the standard deviation, more is the dispersion, correct. More is the variation and less is the reliability of our finding. If we repeat it, we may get different value if the variation is more. So this statement is also true. Okay, right. Now Now we will see another measure of the dispersion, which is called as the interquartile range. So what are the salient features of interquartile range? Now let us see the examples here. What are these examples stating us about? So there are about 100 women who have appeared in this exam, and these are their scores, which are arranged in increasing order. So here n is equal to 100 and n is equal to even number. So it is already arranged in increasing order. Now let us see what is the median here. We remember that n, when it is even number, when n is the even number, the median is the average of the centralmost values, two values. Now it is n by 2th value and the next value. What is n by 2? 50th value, and the next value is the 51st value. 50th value is 58, 51st value is 59. The average is 58.5. So what is median? Median is nothing but the average of these. So 58.5 is the median, right? So median is also called as the 50th percentile. Okay, right. So it is called as a quartile 2 and 50th percentile. It is nothing but the median. We will see what is this quartile 2, etc. Now, if median is also called as the 50th percentile, then what is the 25th percentile? You can see the 25th percentile is 1/4 of the value and the next value, average. 1/4 of 100 is sample size is 25th value, and next value is the 26th value. So it is average of this 45 and 45, which is equal to 45. Then this becomes the 25th percentile. Okay. So now this is 25th percentile. If 50th percentile is called as a quartile 2 and 25th percentile is called as a quartile 1, then what is the quartile number 3? What is the quartile number 3? So if this is the quartile 1, so this is the quartile 1 and this is the quartile 2, then what is the quartile number 3? Is quartile number 3 is the 3/4 the n and the next value, 3/4 the sample size and the next value. It is 75th value and the 76th value, right? And then it is average of these two. So it is quartile 3, that it is 71. Okay. So now what percentage of the data lies between quartile 1 and quartile 3? So what percentage of the data lies between 25th percentile and 75th percentile? It is 50% of the data. So it is called as the interquartile range. Interquartile range is a range between the quartile 2 and this is quartile 1, okay, and median is the quartile 2, and interquartile range is the difference between quartile 1 and quartile 3. Okay, it contains the 50% of the data. Now suppose if the highest marks instead of 85 was 100 or the lowest mark instead of 35 was 0, would it have affected the interquartile range? No. That means extreme outliers do not affect the interquartile range, similar to median, right? So it is better measure of dispersion when the population is not normally distributed. So median is a better measure of central tendency when the population is not normally distributed. Similarly, interquartile range is also a better measure of dispersion when the population is not normally distributed. So this is about the interquartile range. Now we will see more about the interquartile range. So which of this following statement is true about the interquartile range? Interquartile range considers all values to calculate the dispersion. Does it consider all values to calculate the dispersion? No. Okay, it does not consider all values, unlike standard deviation. It only considers quartile 3 minus quartile 1 value. That's all. Okay. So interquartile range is a better measure of dispersion when population is normally distributed. No. Standard deviation is the better measure of dispersion when population is normally distributed. Because interquartile range will not consider all values. Okay. So that is why when normally distributed, standard deviation is a better measure of dispersion. Interquartile range is affected by extreme outliers. No, this is also false. Interquartile, as we saw, range is not affected by the extreme outliers. Interquartile range is not a better measure of dispersion when population is not normally distributed. This statement is also false. Means Interquartile is actually a better measure of dispersion when population is not normal distributed. All the above are false. Okay, so these are the statements about the median. Now coming to diagnostic accuracy tests. These are the tests which are diagnostic accuracy tests which will predict the disease, right? Their predictability is more in this. They are the probabilities which we are calculating. Okay, so which are those diagnostic accuracy tests? So you can see true positive rate. This is one of the diagnostic accuracy tests. True positive rate. What does it indicate? It is the ability of the test to correctly detect those with the disease. Okay, we will see the explanation. Next one is the specificity, which is also called as true negative rate. What it is? It is the ability of the test to correctly detect those without a disease. Without a disease. Okay. So what is true positive rate? It is nothing but sensitivity. Sensitivity is the ability of the test to correctly detect those with disease, whereas specificity is the ability of the test to correctly detect without a disease. Now, what is positive predictive value? It is the probability that a subject who have tested positive truly have a disease. And what is negative predictive value? It is also a probability that those who have tested negative truly does not have disease. What is positive likelihood ratio? It is the likelihood of disease in those who tested positive. What is negative likelihood ratio? It is likelihood of those without disease in those who tested negative. Likelihood of no disease in those who tested negative. We will see one by one. So now when we see, these are the false negatives and these are the true negatives. That means false negatives means test is negative but the disease is there. True negative means test is negative, disease is absent. Now these are the false positives, means test is positive, disease is absent, and these are the true positive. Disease is present, test is also present. That means all these are with disease or outcome. Okay, and all these are without disease or without any outcome. Okay, now we will see what is sensitivity. Sensitivity is probability of a test to be positive in those with the disease. That means how many are true positive? These many are true positive. Okay, and amongst whom? Amongst those with the disease. Amongst those with the disease. That means sensitivity is true positive by true positive plus false negative. Now what is specificity? It is the probability of a test to be negative in those without disease. So these are the without disease. All are without disease. And this is the probability of true negative. So okay. So true negatives that's why it's called as true negative rate. Okay. Now we will see this double bump graph. What will happen? Now we will see this double bump graph. What will happen? Right? Okay. Now you can see when the test is 100% sensitive. When the test is 100% sensitive, that is here. You can see this 100% sensitivity is the point A. At this cutoff value, 100% sensitive, at this cutoff value, okay, it tests negative. It tests negative. Below that, it tests negative. Then we can definitely rule out the disease. So it can definitely say there is no disease. Now, if the test is 100% positive, so specific, 100% specific, and its cutoff value is here, that is C, 100% specific test, and it tests a positive. So definitely we can rule in the disease. So when an 100% sensitive test is negative, we can rule out the disease. So you can remember SNOUT. When 100% test is positive, specific test is positive, 100% specific test is positive, you can rule in the disease. That is SPIN. Okay. So this is the characteristic about these 100% sensitive and 100% specific tests. Okay. Now we will see with the help of this graph, double 2 by 2 diagram, what are these findings? We will help of this 2 by 2 diagram. What are these findings? Suppose this is the truth. Okay, this is the test and this is the test, right? Suppose this is the test. Test is positive. Patient also has the disease. Then it is called as a true positive. Test is negative. Patient do not have the disease. Then it is called as true negative. Similarly, test is positive, but patient do not have the disease. Then it is false positive. Test is negative, but the patient has the disease. Then it is false negative. So this is how we write it in the 2x2 table. Now, what is the sensitivity? Sensitivity is, you can see how many are tested positive in those who has the disease. How many are tested positive in those who has the disease? That means true positive by true positive plus false negative. Then what is sensitivity? How many are specificity? How many are tested negative in those who do not have the disease? This is specificity. So it is true negative by true negative plus false positive. Okay. Now what is positive predictive value? You can see in those who are tested positive, how many are actually having the disease? This is true positive by true positive plus false positive. Positive predictive value. Then what is negative predictive value? In those who are tested negative, how many actually do not have the disease? It is true negative by true negative plus false negative. Right. So what is the prevalence? Prevalence is now what is prevalence? Prevalence is those who are having the disease compared to all. That means those who are having the disease with respect to all. So this is called as prevalence. Now, what is likelihood ratio plus? It is nothing but sensitivity by 1 minus specificity. When you write sensitivity and specificity, you do 1 minus specificity. That becomes prevalent, likelihood ratio positive. That means sensitivity is true positive rate. Specificity is true negative rate. So what is 1 minus specificity? It is false positive rate. So true positive rate by false positive rate. That means the likelihood that it is tested positive in those with the disease compared to it is tested positive in those without disease. Then what is the negative likelihood ratio? It is opposite. 1 minus sensitivity by specificity. Okay. So here we are writing 1 minus sensitivity by specificity. What is sensitivity? True positive rate. Then what is 1 minus sensitivity? It is false negative rate. Specificity, we all know it is true negative rate. So likelihood ratio negative is true negative rate by false negative rate. That means it is tested negative in those who are tested not having the disease compared to tested negative in those who are having the disease. That is true negative rate by false negative rate. Now let us see what is the effect of prevalence on positive and negative predictive value. Now as the prevalence increases, you can see the positive predictive value decreases. Whereas as the prevalence increases, you can see the positive predictive value increases. Okay. And the negative predictive value decreases. Okay. So you can see as the prevalence increases, positive predictive value increases and negative predictive value decreases. Whereas sensitivity and specificity is not affected by this prevalence because they are always inherent characteristics of the test and unaffected by the population. For example, in developed countries where the prevalence of the tuberculosis is low, positive predictive test value of the MON2 test is low. And it is of not much use because sensitivity of it is always low, sensitivity and specificity. Whereas in developing countries where the prevalence of the tuberculosis is high, positive predictive rate or the value of the MON2 test becomes higher. So it is little bit useful there. Okay. So this is the example and relationship between prevalence and the predictive values. Now, what is this graph? This graph is the ROC curve. What is this? It is the ROC curve. What is the meaning of ROC curve? Receiver's operating curve. So you can see when we plot the false negative rate, when we plot the false positive rate. What is false positive rate? 1 minus specificity on the x-axis. And when we plot this sensitivity or the true positive rate on the y-axis. Okay. And we compare them. So at this false positive rate of 10%, at this false positive rate of 10%, what is the true positive rate? 80%. Okay. At this false positive rate of, let us say, higher, 80%, what is the true positive rate? Okay. False positive rate is 80%. Okay. And what is this? So this is what we compare. So when we compare, we get a graph. So area under this curve will tell us how accurate this test is. Area under this curve will tell us how accurate this test is. Now, if the test is worthless, meaning if the test is worthless, then what is the meaning? It is 50% diagnostic accurate test. It is the 50% diagnostic accurate test. Okay, this is the worthless meaning. The area is under 50%. So if it is more accurate, then the curve will be somewhat skewed towards it. So ROC curve is drawn to find out the relationship between true positive rate and the false positive rate. Okay, so true positive rate and the false positive rate. So you can see as the false positive rate is less, you can see at this point highest true positive rate is seen. So what is this false positive rate? 0.1 means true negative rate is 1 minus false positive rate is 90% specificity. Then it is 90% sensitivity. When it is 90% specificity, then it is 90% sensitivity. Okay. So that is how it goes. Right. Now, how to calculate if prevalence was 10%? How to calculate if prevalence was 10%? Total population was at 1000. True positive were 95 and true negative were 810. What is the sensitivity, specificity, positive predictive value, negative predictive value, and the likelihood ratios? Let us see one by one. Okay. So prevalence means what? The total disease in the total population. So 10% means 10% of 1000 is 100. So 1000 is the population size. 10% is the prevalence means 100 have thrombosis. Okay. 100 have the thrombosis. Now, true positive was 95, means those who tested positive and had the disease were 95. So, if 100 were having the disease, then how many were not having the disease? 900, right? Not having the thrombosis. The true positive was 95, means those who have the tested positive and having the thrombosis, 95. Then what is the false negative? It is 5. Okay. Now, if true negative was 810, that means those who tested negative and did not have the disease, then what is the false positive? It will be 90, right? So now we've filled up the 2 by 2 table. Now we will calculate the sensitivity. So what is sensitivity? True positive by true positive plus false negative. It is equal to 95%. What is specificity? True negative by true negative plus false positive, which is equal to 810 by 900, 90%. So it is a 95% sensitive test, 90% specific test. Positive predictive value, we can see the left to right arrow there. It is true positive by true positive plus false positive, which is equal to 51% positive predictive value. What is negative predictive value? We can see the right to left arrow there. It is 810 true negative by total. that is true negative by true negative plus false negative. It is 90%. Right? Now we calculated sensitivity, specificity, positive and negative predictive value. We will see likelihood ratio. So sensitivity by 1 minus specificity. That means here 0.95 divided by 1 by 0.9. That means equal to 9.5. What is negative likelihood ratio? 1 minus sensitivity by specificity. That means 1 minus 0.95 divided by 0.9, which is equal to 0.05. So we can see likelihood ratio is 9.5, positive likelihood ratio, and negative likelihood ratio is 0.05. More than 1 is good for positive diagnostic, good diagnostic accuracy test. If the likelihood ratio is more than 1, and more than 10 is very good. Okay, 5 to 10 is a moderate useful test. If less than 1 is good, negative likelihood ratio of less than 1 is good diagnostic accuracy test. Less than 5 is, less than 0.5 is again moderately useful tests. Okay. Now we will see how to calculate pre-test probability, pre-test odds, post-test odds, and post-test probability. Same problem we have taken here. We have already calculated the sensitivity, specificity, positive and negative predictive value. Now, what is pre-test probability? We have to remember here that pre-test probability is nothing but prevalence. So, what is the prevalence here? 100 out of 1000 have the thrombosis. That is the prevalence. So, prevalence is 10%. So, pre-test probability is nothing but prevalence, which is equal to 10%. Now, what is pre-test odds? You have to always remember the relationship between the probability and odds. The formula is odds is equal to probability divided by 1 minus probability. Now, here, what is probability? 10%, 0.1. 1 minus 10%, that is 0.9, which is equal to 0.11. That is 11% is the pre-test odds. Okay. Now, what is post-test odds? See, to calculate post-test odds, we need to multiply the pre-test odds with the likelihood ratio, right? So, post-test odds is equal to pre-test odds of the diagnostic test multiplied by the likelihood ratio. We have calculated the likelihood ratio as 9.5, pre-test odds as 11%. So, this is the multiplication. We get 1.045 as the post-test odds. Now, how to calculate post-test probability? We need to again go back to the relationship between probability and odds. So, post-test probability is post-test odds divided by 1 plus post-test odds. That is 1.045 is the post-test odds divided by 1 plus 1.4045, which is equal to 51%. Now, pre-test probability how much? 10%. Post-test probability how much? 51%. What is the meaning of this? After doing the test, the probability of detecting the disease or thrombosis has increased from 10 to 51%. And this increase in the probability of detecting a disease after doing the test depends upon the sensitivity and specificity. If the sensitivity of the test is more, that is the numerator is more, and the specificity of the test is also more, that is 1 minus specificity means denominator is less, then the likelihood ratio will be more. If the likelihood ratio is more, then the post-test probability will become more. So what will affect the ability of the test to improve detectability of the disease? So I will repeat, what will help the ability of the test to detect the improve the detectability of the disease? It is the likelihood ratio. That means more sensitivity and more specificity, the test will improve the post-test probability. So this is how we calculate. Suppose a patient comes to an OPD, the prevalence of the disease was only 10%. You ordered a disease test, specific test for thrombosis, let us say, okay, fibrinogen degradation products or something like that. Now, when we ordered it, after the ordering, when it comes positive, the detectability, those who are tested positive, the probability has improved 51%. So that's the meaning on calculation of this pre-test and post-test probability. Okay, so now what is this likelihood ratio explanation? If the likelihood ratio positive is 1 to 2, okay, it is a minimal change to post-test probability of the diagnosis. It is a minimal useful. If the likelihood ratio is 2 to 5, there is a small change to post-test probability. So it is mildly useful. If it is 5 to 10, there is a moderate change in post-test probability. So maybe 50 to 60% change. So it is moderately useful. And if it is more than 10, there is a significant change to post-test probability of the diagnosis of the disease. So it is a better diagnostic accuracy test. Similarly, if the negative likelihood ratio is less, between 0.5 to 1, it is less useful. Between 0.2 to 0.5, small change. Between 0.1 to 0.2, moderate change. And when it is less than 0.1, so when the negative likelihood ratio is lower and lower, it becomes more and more diagnostically accurate tests, more and more useful tests, because it changes post-test probability significantly. Whereas positive likelihood ratio, as it is becomes more and more, then the diagnostic accuracy of the test becomes more and more and becomes more important test to change the post-test probability. Okay, so today we discussed the measures of central tendency, mean, median, and mode, and we also discussed the measures of dispersion, standard deviation, interquartile range. We also discussed the distribution curves and the effect of this distribution on the measures of central tendency and dispersion. Then we discussed the diagnostic accuracy tests, sensitivity, specificity, positive and negative predictive value, and the likelihood ratios, how to calculate them. We also discussed how to calculate the pre-test versus the post-test probability using the using these understandings. Okay, so this for the test, and this is our details. You can see we from StudyMEDIC group not only cater to national and international courses. Okay, we also cater to many MRCOG courses, NEET PG, vaginal surgery, FMGE, reproductive medicine, MRCS, MRCPH course, even to FRCS, USML, and all these courses. You can see the details. And even 2-year clinical, non-clinical programs are available with us. And if you subscribe to our program, you will get the live sessions, detailed live sessions on all these topics, and free access to the libraries divided on these topics, mock tests, and group discussions, and many other useful resource materials. Okay. So if it is useful for you, please share and like, share, and subscribe our channel. Okay. Thank you.